so a tangent segment, or a tangent line, is a line that touches a circle only once. Like if I had a circle and my line touches a circle more than once, like it crosses through, that's not a tangent segment. That would be a secant segment. But I know lines we cannot measure a line because they go forever. So what we're gonna do, we're gonna have segments, and I know a segment is part of a line. So the interesting part on tangent segments that meet outside of the circle, so the two tangent segments that meet outside of the circle, they're equal to each other. So in my case, we can see the two tangent segments, they meet outside of the circle, so I'm gonna let them equal each other. So I'm gonna say 4x plus 3, 4x plus 3 is equal to negative 3 plus 3x. Or 5x. Negative 3 plus 5x. And then I know we can separate the sides to the equal sign because the instructions are said solve for x. So what I'm going to do, I'm going to have x's on one side. So my 4x from one side, let me move it as a negative 4x on the other side. My negative 3 from the right, let me move it as a positive 3 on the left. Remember, I switched the sign. So I have that 6 equals, I know 5x minus 4x is 1x. So x equals 6. Just that simple. Right? Two tangent segments that meet outside of the circle are equal to each other. I might give you the radius, like in question number 4. I think I write 40.3 for the radius. For the radius, I might give you the radius, but you don't need that number. I said, even though it's there, you don't need it. Just look at the two tangent segments. Let them equal each other and you're good. That's all we're doing on the front. So any questions on the front? No? Simple? Ignore the radius now.
Then why do you give it to us?
So you know what's important. So, no questions on the front, Tim? Ignore the radius, yeah. If I give you the radius, once again, if I give you a radius information, ignore it. Like there's a relationship that it creates angles, but that's for tomorrow. But for the side, the length of the sides, ignore the radius. The radius has nothing to do with it for today. All right, now on the back, no, it's okay. You guys, it's fine. I'll wait. You guys good? Okay. Now on the back, it says find the perimeter of each polygon. I notice I have a triangle. It says assume that lines which appear to be tangent are tangent. So I know that two tangent segments that meet outside of the circle are congruent. So I notice this little part right here says 7.3. So I'm going to say this other part right here, it's also 7.3. Right? These two tangent segments that meet outside should be the same length. Now looking on this entire side, right here, the one that I have my cursor, the whole thing is 14.6. Part of it is 7.3. Let me subtract them. And I'm going to get the remaining is 7.3 as well. Right? By coincidence, it was the same number. So I know the two tangent segments, yes.
Yeah, it's like a really bad glare.
We have a big back glare. Is that better? Probably good?
Yeah.
Yes. Even for you? It was a bad glare. Okay. So once again, looking at that, we know this bottom part is 7.3. Hold on, now my airliner froze. Gotta love technology sometimes. Alright, let me wait. Once again, technology, I love it only sometimes. Just one thing that, okay, there it is. let me start the question all over. We know that this is 7.3, so that's how I came out that this other part was 7.3, because two tangent segments that meet outside have the same length. Then I was looking at this bottom part, 14.6. I subtracted 7.3 from it, so I found out that the remaining part was 7.3. So this is 7.3. This has to be 7.3 as well. I need to find out what's the length of the rest, but I'm going to come around. I know that this whole thing is 18.3. Part of it is 7.3. Let me subtract them, and I'm going to find out that this side is 11. If this side is 11, I'm going to say this other part right here is also 11. Remember, two tangent segments that meet outside are congruent. So now for my perimeter, I know this whole side is 18.3. I know this bottom side, the whole thing is 14.6. And I know on this other side, the whole thing is 18.3. Right, I added those two numbers. The whole side is 18.3. Now add your three sides, and you should get 51.2. The idea is two tangent segments that meet outside have the same length. Pretty much what you guys did on the front. It's not always triangles, so let me look at number 13. Let me find out how big the measurements are. I see this side is 9, so I'm going to see this other side right here. It is also 9. Right, this is 9. This is 9. What is it? Why is this 9? Huh? Because I see that these two segments are tangent. They meet outside, so they have to have the same length. So this is 9. Now looking at the whole thing is what? 15.5? Part of it is 9. So subtract it, and you're going to get this bottom part is 6.5. So this is 6.5. I'm going to say this little corner here, it is 6.5 as well. If I look on this other side, this side is 10. So I'm going to say this little part right here should also be 10. The entire side is 16.3. So I'm going to say this little corner here it is 6.3, and this other corner here it is 6.3. Right, two tangent segments that meet outside have the same length. So now, this whole side here it is 16.3, right? That was given. On the opposite side is 15.5. Now the side on the top, I'm going to get 15.3 because I added those two numbers. The thing at the bottom, the segment at the bottom, I'm going to get 16.5 because I added those two numbers. So now add the four sides, and you should get 63.6. Does that make sense?
Can you do another one of those?
Another one of these?
Yeah.
Like which one?
Just input those.
18?
Yeah.
All right, let's take a look at 18. Is it okay with you guys if I move 18 to the right? Like that? Because I know most of you guys have a glare here on the left. All right, so looking at 18, if this side right here it is 5, I'm going to say this other side right here it is 5 as well. Right? Notice two tangent segments that meet outside. I know the whole thing up here is 15. Part of it is 5. So I'm going to say the remaining is 10. And if this is 10, this other side right here it is 10 as well. If I look at the bottom, I'm going to call this little side 6.6. Because I know it has to be the same as this. Now on this other corner, I'm going to call this side 8.4. And the way I came up with 8.4 because I had 15 subtract 6.6. So this is 8.4. I'm going to say this other corner, other side right here, it is 8.4. Now for my perimeter, I know on the top is 15, at the bottom is 15, on the left I have 16.6, and on the right I have 13.4. You guys see where I got my numbers from? Add everything, and that will be your perimeter. This is what? It's 16, 17, 60. My focus here, like seriously, my focus here, you notice these two are the same, 8.4, 8.4. Now in this other corner, 6.6 with 6.6, 10 with 10, 5 with 5, and then obviously add everything. All right. Any questions? Which one? 12. All right, let's take a look at number 12. I know this bottom part is 9.6, so I'm going to say this part right here should also be 9.6. Now, on this side, the whole thing is 23.6. Part of it is 9.6. Let me subtract them, and I'm going to say this side is 14. Obviously, on this other side, this is also 14. Now, looking here at the bottom, this is 9.6. I'm going to say the remaining is 10.1, because I subtracted 19.7 minus 9.6. So this is 10.1. This other side is 10.1. So for my perimeter, I'm going to add 19.7 plus 23.6 plus 24.1. And I'm adding the whole side. You guys might be like, well, if I knew this side was 23.6, why did I have to figure this was 9.6 and this was 14? If combined is 23.6. I needed those numbers to eventually know that this side was 14. So even though I knew this whole thing was 23.6, I had to figure out those two numbers to figure out that this side was 14. So you needed to do that eventually. You add all that, and it should give you 67.4. Okay. Any questions? Simple? Yes. Let me take over the trick.